Hi, my name's Ellie, and today I'm going to talk a little bit about the device we made. So the first step before introducing anything is to calibrate it. So you got a little preview of what our device is just now with the words night medicine, and essentially what our device is it's a reminder for patients to understand when they have to take their daily medicine, and so this comes in the day and at night. So most people have to take their medicine twice a day, and if they miss out on either the day or the night medicine, the side effects could be deadly. And so essentially how this device works is right now the stimulation is at night, and so if you pan over to the device, this is night, and you can save by night medicine. Now, if we shine the light, it stimulates that the sun has come out and it's in the day. And as you can see, the LCD changes to morning medicine with the little suns, and there's also a tone that's specific to morning medicine. If you remove the flashlight and cover it up, it turns back to night medicine with the crescents. So the importance of this device is, once again, just to remind patients they have to take both their morning and night medicine. There are a couple of components that come into this device, quite a few actually, and that's what Caroline will be introducing next.
Hi, I'm Caroline and I'm introducing the hardware. So we have a few components that go into our circuit. So this right here is the piezo. It makes noise by vibrating, which alerts the user whether it's the night medicine or the day medicine and when to take it. This is the potentiometer, and when you twist it, it changes the contrast of the LCD. And this is an LED which lights up when it tells you when to calibrate. And this is the phototransistor. So basically the way that the Arduino can tell whether it's day or night is by how much current is flowing through the phototransistor from the light that it's absorbing.
Hi, I'm Zach. I'm going to introduce the code here. So the first step we do is we include the liquid crystal library. This is a public library on the Arduino site, and we need it to use the liquid crystal commands later in the code. Now here we have some initial information. These are the arrays for our custom characters that we're using in our Arduino, and so they'll be displayed on the LCD later with the current commands we'll use. These just set up the information for them. Here we initialize some variables here. So we have sensor value, which will be the reading from the phototransistor on the analog pin. We have sensor low and sensor high. These will be used during the calibration period that I'll get into a little bit later. And then we have the LED pin and piezo pin that we'll use later in our digital writes. And now we have, this refers back to the characters I referred to before. We have the LCD create character for the sun and the moon that we'll use for day and night medicine. And then in the setup, we begin our LCD stating that there are the two rows and 16 columns. So here, for the calibration, we make our LED pin an output, and we digital write the LED pin to high at first. Now we have a while function here for the actual calibration period itself. During this, the sensor value is read from analog pin A0, and if the sensor value that it reads is higher than the set sensor high above, it changes the sensor high to that value. If it's the same thing for the sensor low, if it's lower, it changes the value to that. And this all occurs in the 5-second period, and then when that's over, the LED is written to off, and then the loop process begins. So here, again, during the loop, the sensor value is read from analog pin A0, and different statements are accomplished based on the value of that. If the sensor value is equal to sensor high from the calibration before, it plays a certain tone on the piezo it reads the piezo pin, has the tone value here, which is associated with certain sound from the vibrations, and the length of the tone. There's a delay, and it does that multiple times to create the alarm sound. After that, the LCD cursor is set to the origin point 00, and it prints the morning medicine alert. Here, then the LED cursor is set to the second row, and it prints the characters above to show that this would be daytime for this current situation. Then it plays the alarm again to remind the person again to take their medicine. We have the other case now of sensor value equals sensor low from the calibration. It plays an alarm, but at this time at a value of 2000, which corresponds to a different sound. Then it does something similar. It sets the cursor to 00 and displays night medicine. A delay occurs, and then it sets the cursor to the second row and displays the moon symbols that we had filling the entire row. Another delay occurs, and it plays the alarm. And this is the entire code for the system.